Welcome back to Stewart Science. This is a really quick video to talk about Newton's third law. Now this is a law that is really famous. You always hear it mentioned in movies. I want to tweak a little bit the way that people usually talk about it though. So you usually hear Newton's third law said, every force has an equal and opposite reaction. That's what you normally hear. Now I don't really like that word reaction in that statement because it kind of implies that one force happens and the other one like has a delay or like happens later, or like one force is the action, one's the reaction. That's not exactly how it happens. Really, it's better said like this: forces come in pairs. So forces are interactions, they're pushes and pulls between two objects. And so when one object pushes on the other object pushes back with an equal force at the same time. Not that it's a reaction, but that it's a simultaneous paired action. So you'll hear me call these, pardon my awful handwriting, force pairs. Forces always come in pairs, and every pair is always equal. So for example, when I was in middle school, I got in a fight with a kid, and I got mad at him. And rather than punch him, I walked into the gym at a middle school dance, and I punched a gym mat. And that gym mat broke my hand. I literally had to wear a cast because the force that my fist exerted on the wall, you have the force of the fist on wall, and then the paired force is the wall exerts an equal force at the same time on my fist. So I exerted a force on the wall. The paired force was wall on fist. And so the trick here is all you have to do to identify the force pair is flip the objects. So if you have the force of the fist on the wall, the paired force would be to just flip those two objects. So it would be the force of the wall on fist. It's always how it works. If you have the force of the tire on the road, the paired force is road on tire. If you have the force of the earth on us, the paired force would be us on earth. Here's another example. You have the force of the dog on the rag. The paired force would be rag on dog. Or if you want to look at this as an interaction between the dog and the person, you have the force of the dog on person and the force of the person on the dog. So there's an equal force, just flip the objects. So here's the only way I could trip you up. I like to end these videos with where will you likely get tripped up. So here's what I could do to trip you up. I want you to think about the forces on the trailer and the forces on the tractor. So think about this. The trailer is exerting a force on the tractor right here. And the tractor is exerting a force on the trailer in the same place. And that's a force pair. If the trailer pulls on the truck, if the trailer pulls on the tractor pulls on the truck. They have to be equal. Even, this is so weird to think about, even when they're accelerating. And here's why. When they're accelerating, the forces on the individual objects are not equal, like we've already said. If the tractor is gaining speed, that means that the net force has to be bigger this way, which means that the force of the engine has to be bigger than the force of the trailer. So the forces on the individual object, the tractor, are not balanced. Same thing with the trailer. The trailer has to have unbalanced forces or it wouldn't be changing speed. And so the force of the tractor needs to be bigger than the force of friction for the trailer. But the issue is this force and this force have to be the same. The force of the trailer and the tractor is the same as the force of the tractor on the trailer, even when they're gaining speed. As always, this is Mr. Stewart. Keep learning, no matter what.